Welcome to GCSE Maths Help. Today we're going to be looking at probability and the key points you need to know for your exam. We're going to cover tree diagrams, Venn diagrams and sample spaces in this video. But first we're going to start with the basics. Let's get started. Probability is the likelihood that a certain outcome happens. This might be rolling a number on a dice or picking a coloured pen at random. Probability can be expressed as a fraction or as a decimal between the values of 0 and 1, 0 being it will never happen and 1 being it's certain to happen. The probability of event A happening is written as P with the event in brackets. The probability of event A not happening is written as P with A dash in the brackets. The more complicated questions will ask you the likelihood of two events happening together. The key to calculating the probability of two events happening is usually based on whether the outcome of the first event affects the outcome of the second event happening, whether the two outcomes are independent or dependent on each other. For example, if you select a coloured ball from a bag and then replace it, the probability you select the same coloured ball is the same the second time round because the total number of balls in the bag is exactly the same as it was before, so these events are independent of each other. However, if you select a red sweet from a bag and eat it, the probability of selecting another red sweet will change the second time round because there's now less sweets in the bag, so these events are dependent on each other's outcome. To calculate event A or event B happening, we add together the probabilities of each one occurring. To calculate event A and event B happening one after the other, we times the probabilities together. Sometimes the questions are asked with these symbols you can see on screen, so you need to know which one is which. I remember the AND symbol as an N, which is in the word AND. Let's have a look at an example. A bag contains 5 red counters, 4 blue counters, 6 green counters and 5 yellow counters. We're going to say that event A is that we pick out a red counter. So the probability that we pick out a red counter is 5 counters out of the total 20 counters that are in the bag. Let's say event B happening is that we pick out a green counter. So the probability that we pick out a green counter at random is going to be 6 green counters out of the bag of 20. So we can have a think about the probability of two events happening together. So if we picked a counter at random, the probability that it was red or green will be written as the probability of event A or event B happening. So this will be the probability of event A happening plus the probability of event B happening. So we've got 5 out of 20 plus 6 out of 20 is equal to 11 out of 20. So the probability that if we pick one counter at random, it's either red or green is 11 out of 20. If we pick a counter out of the bag and then replace it and pick a second counter out of the bag, we can work out the probability that the first counter is red and the second counter is green. So that's the probability of event A and event B happening. So this time we need to times the probability of event A happening by the probability of event B happening. So the probability that the first counter is red is 5 out of 20. Because we've replaced the counter and then picked another one, these two events are independent of each other. So we can times it by the probability that the second one is green is still 6 out of 20 because there's still the same amount of counters in the bag the second time round. So that will give us 30 out of 400, which we can simplify to 3 over 40. So there's a 3 out of 40 chance that if we pick one counter out of the bag it's red and then replace it and the second counter we pick out is green. For questions about probability, you often need to think about all of the outcomes that could happen if an event occurred. This is often called the product rule, finding the total number of outcomes that could happen. For example, if a cinema has a choice of 3 packets of sweets and 6 different films to watch, how many possible combinations are there of sweet choices and films chosen to watch? So if we write all the sweet choices out as A, B and C, and the film choices as 1, 2, 3, 4, 5 and 6. You could choose Sweets A and watch film 1. You could choose Sweets A and watch film 2. You could pick Sweets A and watch film 3. Pick Sweets A, watch film 4. Pick Sweets A, watch film 5. Pick Sweets A and watch film 6. Or you could pick Sweets B and watch film 1. Pick Sweets B and watch film 2. Pick Sweets B and watch film 3. Pick Sweets B and watch film 4. Pick Sweets B and watch film 5. Pick Sweets B and watch film 6. Or you could pick Sweets C and watch film 1, and so on. So that shows us that there are 18 possible combinations from 3 sweet choices and 6 film choices. So in a question in an exam, you can write out all these options, or you could do the 3 sweet choices times the 6 film choices is 18 options. Another way to show this is to put it in a sample square. So a sample square shows all of the possible outcomes of 2 events happening. This time we're going to have a look at the score you can get by rolling 2 dice and adding them together. So you can see that we've got all of the outcomes you can get with dice 1 along the top, and all the options you can get with dice 2 down the side, and in the middle of the sample square are all the scores you can get when we add the 2 scores together. So we can see that there's 36 boxes filled, so there must be 36 different outcomes that can happen, or 6 options from dice 1 times 6 options from dice 2. So from this sample square, we can calculate the probability of getting a certain score from rolling these 2 dice. So we know that these 2 events are independent from each other because whatever number you get on the first dice doesn't affect whatever number you get on the second dice, as they're 2 different dice and they're not biased. So the number they roll is at random. So let's have a think about the probability of if you roll these 2 dices, you getting a score of 10. So we can see from the sample square that this happens 1, 2, 3 times. So the probability is 3 divided by the 36 possible outcomes, which we can divide top and bottom by 3 to give us 1 over 12. This time, let's have a look at the probability of getting a score of 4 or getting a score of 5. So we need to add together the probability of scoring a 4 with the probability of getting a score of a 5. So the probability of getting a score of 4 is 1, 2, 3 out of the 36 possible options. Getting a score of 5 is possible in 1, 2, 3, 4 instances. So we've got 4 over 36. So we can add those together to get 7 over 36. So the probability of scoring a 4 or a 5 is 7 out of 36. Another way to draw probability is with a tree diagram. This shows all the options that could happen at each event and the probability of them happening. So here we have balls being taken out of a bag. There are 5 red balls and 5 yellow balls. So on the first branches of our tree, if we select a ball at random, the ball is either going to be red or yellow. So the probability that the ball is red is 5 red balls out of the 10 balls in the bag. The probability that the ball is yellow is 5 yellow balls out of the 10 balls that are in the bag. If we were to have a second event, if we took another ball out of the bag, we can extend the branches of the tree. So the key here is that we're not replacing the first ball that we took. So the second probabilities of taking another ball are going to change because there's now less balls in the bag. So on the first branch of our tree, when the first ball that we took was red, if we take a second ball, it could either be red or it could be yellow. So the probability of the second ball being red is going to be 4 because there's now 1 less red ball in the bag, divided by 9 because there's only 9 balls left in there. The probability that the second ball is yellow is going to be 5 because there's still 5 yellow balls in the bag out of 9 because there's only 9 balls left in there. So if we look at our second branch now and we take out another ball, it could be red or it could be yellow. So the probability of the second ball being red after the first one was yellow is going to be 5 out of 9 because there's still 5 balls in there because the first one was yellow, but there's only 9 balls left in the bag. So the probability of the second ball being yellow after the first one was yellow is 4, because there's only 4 yellow balls left now out of the 9 balls that are left in the bag. So now we have a completed tree diagram, we can use it to calculate the probability of different events happening. So if we wanted to work out the probability of the first ball being red, we can see from the tree diagram that that's 5 over 10 or a half. We can read that straight from the diagram. But if we wanted to calculate the probability of both balls being red, we need to read across the branches to see what happens. So the event is that the first ball is red and the second ball is red. So we need to times the probability of the first one being red by the probability of the second one being red. So we go along the branch, first one is red, second one is red, and do 5 over 10 times 4 over 9. So that gives us a probability of 20 over 90 of both balls being red, which we can simplify to 2 over 9. Next, we're going to calculate the probability that if we pick 2 balls at random, they're balls of different colours. So we need to have a look along the branches of when this happens. So we've got the first ball is red and the second ball is yellow, and we've also got the first ball is yellow and the second ball is red. So this is 2 branches that we need to calculate. So the probability of the first one being red and the second one being yellow is 5 over 10 times 5 over 9, which gives us 25 over 90. So then we want the probability of the first ball being yellow and the probability of the second ball being red. So we'll do 5 over 10 times 5 over 9, which gives us 25 over 90. So to find the total probability of us picking 2 balls at random and there being a ball of each colour, we add 25 over 90 plus 25 over 90, which is going to equal 50 over 90. So then the last thing I need to tell you about probability trees is that when you get to the end of the branches, all of the probabilities there will add up to 1, because these are all of the options that could possibly happen. So at the top, we've got the probability of us getting 2 red balls is 20 over 90. The probability of getting a red ball and then a yellow ball is 25 over 90. The probability of us getting a yellow ball and then a red ball is 25 over 90. So the probability of us getting 2 yellow balls is going to be 1 minus these 3 probabilities added together, which will give us 20 over 90. And we can double check that by doing 5 over 10 times 4 over 9, which is 20 over 90. So the last way you could be asked to show probabilities is with a Venn diagram. So in a class of 35 students, 25 of them have cats, 15 of them have dogs, and 10 students have both. Put this information in a Venn diagram. So if we label the first circle as students with cats, the second circle of students with dogs. So to start off with, we can put 10 students there in the middle where the 2 circles overlap, because they've got both a cat and a dog. So if 25 students have a cat and we've got 10 of them already accounted for in our diagram, there must be 15 students that only have a cat. If there's 15 of them that have dogs, but 10 of them are already accounted for in our diagram, there must be 5 left that just have a dog. So if we've got 30 students in our diagram already, but it's a class of 35 students, there must be 5 students that don't have a cat or a dog, so they go on the outside of the circles because they don't fit into either of those categories. So like a tree diagram, we can use this information to work out the probabilities of certain events happening. So if we picked a student at random, the probability that they owned a cat would be the probability of them owning just a cat, which is 15 over 35, added together with the probability that they owned a cat and a dog, which is 10 over 35. So that would give us a total probability of 25 over 35, or 5 over 7. So that brings us to the end of the probability key points video. It's a big topic and there's loads to cover, but the rules for calculating probability are the same whichever diagram you're looking at, so keep practicing if you're finding it difficult. The key is working out whether the outcomes of the two events are independent or dependent on each other. After that, you should be fine. I really hope you found this video helpful. If you'd like to have some practice at answering exam-style questions on this topic, click the link in the bio below. Don't forget to subscribe to GCSE Maths Help with the subscribe button below, or you can check out my Instagram page at GCSE Maths Help for more videos and tips. Thanks for watching.